Good morning and welcome everyone to the Precision Agriculture Cover Crop webinar. I am Dr. Ali Mirzakhani Nafchi, Assistant Professor and Precision Agriculture Extension Specialist here at South Dakota State University. We are kicking off today with our first speaker, Dr. Jiyul Chang. Dr. Chang is a senior lecturer in the Department of Agronomy, Horticulture, and Plant Science. Dr. Chang teaches precision agriculture. He will share his insight on mapping for variable rate application using yield monitors, remote sensing, elevation, and spatial data analysis using GIS and drones for precision agriculture practices. Following that, I am excited to take the stage as your second speaker. My focus will be on improving nitrogen use efficiency using nitrogen-rich spots as biosensor in crop production, where I aim to share my research and insights, hoping to spark meaningful discussion. After our presentation, we will open the floor for Q&A session. This is a fantastic opportunity to engage and ask questions and share your thoughts. Thank you for being here. Let's begin with our first speaker, Dr. Chang. Over to you, Dr. Chang.
Thank you, Ali. I'd like to share my screen first. Can you see my screen?
Yes.
Okay, thank you. Good morning, everyone. As Dr. Nafchi said, my name is Jiyul Chang, and I am a senior lecturer in the Agronomy, Horticulture, and Plant Science Department. Then today, I'd like to talk about the precision agriculture practice, especially the variable rate applications. So outline of today's presentation is first, concept of precision agriculture practice and the benefits of precision agriculture practice, and then variable rate applications, so especially for the fertilizers, and the data. I'll talk about the data to make the variable rate application maps. And if I have time, I'd like to talk about the digital agriculture briefly. Okay, first, concept of precision agriculture. The most basic and the original concept of the precision agriculture was the site-specific measurement. So when you apply this concept to the application, we call this variable rate applications of fertilizers, seed, pesticide, or waters. So to do this, the practice, we need to follow this famous 4R practice. Those are right time, right place, and the right amount with the right sources. So these are basic idea, the concept of precision agriculture. So based on this, we can optimize the input and maximize the productivity and minimize environmental impact. So that's our final goal of the precision agriculture practice. So another term is with this, we can increase the sustainability of our agricultural systems. Then next one is benefits. When you use the precision agriculture practice, what kind of benefits you can get? These are, we have several benefits. The first one is a yield benefit through increased efficiency, fertilizer reduction by more precise placement, pesticide reduction by more accurate applications is a site-specific management, fuel savings due to the less overlap, and then finally we can say water through accurate application as well. So those benefits are from the textbook or mostly. Then I show you the real world survey data. This data is conducted by the Purdue University in 2018. So based on this survey, first I'd like to talk about the left-hand side chart. Left-hand side chart is about the ask to the dealerships. Then when they use a precision ag practice, how much they reduce the input. Then 6% of dealership said they did not reduce any, but 37% of dealership said they reduced about 10% of inputs. Also, 26% of dealerships said that they reduced 20% of input. And then 13% dealership said they reduced more than 50% of the input. So basically, in like this, the more than about the 60% of all dealerships said they reduce 10 to 20% of input. The right-hand side one is they also, this survey asked the dealerships how much they increase the yield when they use the precision ag practice. Then 51% of dealerships said they increase about 10% of grain yield. And 28% said they increase 20% of the grain yield. 5% of dealerships said they increase 40% or more grain yield when they use precision ag practice. Again, almost is 80%. 80% of the dealership said they increase the grain yield when they use precision ag practice. So that is a real evidence, it's very good evidence about the benefit of precision ag practice. So to apply to use this kind of precision ag practice, we need very simple steps. First thing is we need to collect data. As I can say, the precision agricultural practice is the data-based farming. So to do the precision ag practice, we need the data. Without data, we cannot do anything further. So first, we need to collect the data. Second, when you have data, we need to analyze data. Analyzing the data is very, very important to understand your field and also to make the better management decision. And the third one is, especially I like to talk about the variable rate fertilizer applications. Then to do that, we need to make the management zone maps based on the data. And the last, based on the management zone map, we can make the variable rate application map. These simple 4 steps, the process of the variable rate application. So this is a simple example. This is one of our study field. We collect the corn grain yield data from this quarter section field. Then this is 1 year data. Then when you look at this the variations. We call this a spatial variation. Different color represent different grain yield. Especially the red means it's low yield, like that, and the green means it's a high yield. So range of the grain yield is a 68 bushels per acre to the 230 bushels per acre. Then these are the combined the yield monitor data. So these all the point. So I want to apply the variable rate fertilizer applications. Then to do that, we need to simplify this map first. I want to make about 3 or 4 different fertilizer rates. To do that, just for example, here, I just group the yield values in the similar ranges. So I make, just for example, I made 3 different zones, 3 different areas like that. The red means, excuse me, red means the low yield potential area. Yellow means medium yield potential area. And then green means high yield potential area. Then I grouped like this, then I can make this kind of map. We call this management zone map. So green, roughly the yield goal of the green area is 180, the yellow 145, and red area has 110 bushels per acre of yield goal or yield potential. Then based on the South Dakota fertilizer recommendation guideline, to calculate the nitrogen recommendation rate, we need to use this equation, yield goal times 1. Then I don't want to use soil test nitrogen and the legume credit, but right now, in this time. So just use this one. I can apply the 180 pounds per acre of nitrogen in the green area and 145 pounds per acre of nitrogen in the yellow area and 110 pounds per acre of the nitrogen in the red area. This is a variable rate application map, and then we just apply these three rates in this field. So that is the steps. Okay. So to do this, we need this kind of things. So I'd like to talk about the tools for the precision agriculture practice. There are several tools that are required. First one is the GPS. We call this GNSS, Global Navigation Satellite System. Without the GPS the coordinate of the sampling point, we can make the map. Then we can, without map, we cannot do the variable rate application practice. So whenever you go to field, whenever you collect the data, always you should bring your GPS receiver, and then you need to collect the GPS coordinate of every sampling point. So that is the first thing and the most important equipment. Second is a contact or non-contact sensors to collect the data from field. There are many different sensors right now. Third one is a GIS software. GIS stands for Geographic Information System. I'm sure, I hope many of you know SMS, developed by AgLeader. SMS software is the most common right now, common agricultural GIS software. So if you use SMS, you can make the map, many different types of map for the precision agriculture practice. Third one is we need to use any kind of geospatial analysis. So we can use some kind of the statistical software, the packages or Excels. So we can use just simple geospatial statistics to analyze the data to make the good maps. And to do all these kind of things, we need to use a computer. Basically, without computer, we cannot do this because we are dealing with the tons of data. So more data means we can make the more accurate management decisions. So computer is required to do all these kind of things. And finally, we need to use a variable weight technologies. So these are basic tools for the precision agriculture practice. And next one is I'd like to talk about the variable rate application map. So this most common right now in recently, the most common variable rate application map for precision agriculture practice are these. We are nitrogen map, we are seedings, we are liming, we are phosphorus or potassium, and we are irrigation. So, excuse me. So I like to show you the survey result again. Then this one is also conducted by the Purdue University. Then also they ask the dealerships, then what kind of the variable rate application techniques did they use? Then in the 2023, in the last year, they said almost 90% of the dealerships use a variable rate fertilizer application, and the yellow one is the variable rate lime, and the green one is variable rate seeding application. So these are three application techniques in practice are the most common right now. So then to do that, we need to use the data layer. So to make the variable rate nitrogen application map, usually we need to use a multiple year yield map or multiple year NDVI map. To make the variable rate seeding application map, we can use the red band, the image map, or EC electrical conductivity map, or elevation map. To make the variable rate lime application map, we can use the soil buffer pH map from the grid soil sampling data. And finally, to make the variable rate phosphorus or potassium application map, we need to use a soil phosphorus or soil potassium map from the also with soil sampling the result. So these are pretty common. I don't want to talk about the variable rate of water because it is not the big issue in this area. So I like to talk about this each layer just a little bit. Then yield data is very, very useful and the most important data in the variable rate application practice. Because the yield varies due to the soil parameters like the soil texture, drainages, and the landscape, and the measurement practice. And always, when you analyze the data, the dependent variable must be the yield data always. And then we can get the yield data from the combine yield monitor system. So yield maps are best used for the variable rate nitrogen application map. So here's an example. This is also 6-year average the standardized yield. So like this, the roughly based on the landscape, we can classify the 3 different zones, yield zones. This is low, this is a low, and this is medium, a high, and this is mid, the intermediate. So it's like that. So the multi-year yield value is very, very important and useful to make the variable rate nitrogen application map. Second useful layer is remote sensing data. The most common remote sensing data is satellite images, aircraft images, and drone images. Then actually these images contain many informations. Then also very common information we are using is NDVI values. So NDVI is also very important to make the variable rate nitrogen because NDVI is highly related with grain yield data. So let's talk about the NDVI just a little bit more. NDVI stands for normalized difference vegetation index, as you know. So NDVI is the most common vegetation index in agriculture, so especially in the precision agriculture practice. So NDVI, the equation of NDVI is near infrared minus red over near infrared plus red. So why the near infrared band is the most useful in agriculture? Because of this. This is standard the reflectance pattern of the healthy plant and unhealthy plant. So this is blue, the light range, green light range, and the red light range, and this is near infrared. So in the near infrared, the reflectance from the healthy plant and unhealthy plant are significantly different. So because this kind of difference, NDVI identify the healthy plant clearly. So that's why NDVI is very, very useful in the agriculture. So here is another thing. Then the reflectance pattern, when you look at this, the stressed leaf and the healthy leaf, the reflectance pattern of blue, green, red under the stress or from the stressed leaf and the healthy leaf are very, very similar. That means human eye cannot detect the stressed leaf easily because the human eye can detect the blue, green, red only. And then the reflectance patterns or stress leaf as plant as leaves are same, almost the same. That means human eye cannot see that. But when you use a near infrared sensor, the reflectance of the stress leaf and healthy leaf are very different. So that's why when you use NDVI maps can identify the stress plant very easily. So then why and how you can use the NDVI to make the variable rate application map, especially for the nitrogen, because of this. When you compare the near NDVI value and actual grain yield, will clear the positive relationship. Sometimes it's a linear relationship, sometimes it's exponential relationship. But the thing is, though NDVI and grain yield a positive relationship, clear relationship. So because of this reason, we can use an NDVI map to make the variable rate nitrogen application map. Also, we can estimate the grain yield. Here's another example when you compare this to the plant leaf, then these left-hand side, this is a healthy leaf, right-hand side, a stressed leaf, that is near NDVI images. So you can NDVI images and then separate this healthy leaf unhealthy plant clearly like that. Here's another example. And I'll talk about the benefits of NDVI just briefly. First thing, identify the problem sooner. So as I mentioned already, human eye cannot see the stress the plant easily. But when you use NDVI sensor detect the stress plant just almost 2 weeks before human eye can detect. That means we can find out the problem sooner than we can overcome this kind of issue quick. So that is the main things. Second thing is you can scout field faster, so you don't need to walk through the whole field. Instead, we just use the drone images, satellite images, and make the NDVI map. You can find out the problem stress area very quick. Third one is you can create a variable rate prescription map. As I mentioned already, NDVI map can make the variable rate nitrogen application map. Also, you can track the crop hairs. When you collect the NDVI map through the growing season, you can track the crop hairs very quickly. And estimate the crop production. Then with NDVI map makes appropriate time. You can estimate the crop, the grain yield very well. Here's an example like that. So this is NDVI map, and we can make the measurements on map simply like this. Soil test result. Okay, soil test result from the nitrogen, phosphorus, potassium, and the pH map, pH data. We can make the variable rate phosphorus, potassium, and the lime map. Especially in the electrical conductivity. The electrical conductivity is highly related with soil texture, landscape, CEC, and the drainage conditions, soil moisture like this. So it's very useful, and we scan the whole field using the various cards like that. And this is our data. It's an EC map. This very highly related landscape as well. Topography landscape. The landscape position is highly correlated with soil moisture, water stress, and the nitrogen stress, yield variation, soil organic matter content, soil types, almost everything. So landscape or elevation map is very, very useful to make the variable rate seeding application map. It's like that, you can make the simple landscape position map like that. Soil type, okay, soil types is also good for the variable rate nitrogen application map and the seeding application map. So here, this is example of this left-hand side, this is corn grain yield map, and right-hand side is soil type map. When you see these patterns, the patterns of yield variation is very similar with the landscape and the soil types. And then, so right now, I have a 1023 right now. Do you want to keep going to for my presentation, or do you want to stop here and make the questions and answers?
You can continue to 10:30. Then we will have at the end of the presentations questions.
Okay, then I like
Please.
to talk about thank you. I like to talk about the digital agriculture. Digital agriculture is a new term in the last few years because we are living in digital era, so everything is going to digital. But why is the digital agriculture? That is using the digital technologies or tools in agriculture system. Especially it's a digitized data, digital platforms, and wireless communications. So these kind of digital systems include the precision agriculture as well, because precision agriculture uses digital systems and digitize the data. And also, every other operations involved in the agri-food supply and value chains in the digital platform. So basically right now, it's a digital platform cover the whole food chain from the farm to table. So understanding the digital agriculture is understanding the reason and the future of the agriculture system. So there are three components that cause a digital agriculture system. First one is the digitized data. Every data should be in the digitized. Then when you upload this digitized data to the cloud or your computer, the apps, and then in the cloud, the analyze the data for the world. How is like the digital platform. The good example of digital platform is the climate field view. So when you upload any kind of data in the climate field view, the cloud analyze all the data and using the artificial AI, then they make the good management decision for you. So right now, there are so many different types of digital agriculture platform now. And the third one is wireless communication technology. It is very, very important and useful in the digital agriculture system because in the data transfer and there was autonomy. So in I think 5 or 6 years ago, to transfer data, we used the PCMCAA card or USB jump drive. But right now, we don't need to do that. We need to transfer data through Wi-Fi in the real time. So benefits of digital agriculture is can enable better decision making and precise operations. So from the very, very accurate the management decision. So with the digital, farmers and producers have the information to become better planners and executors. Then I will talk about just about the digitized data. Digitized data is the data collected by the digital system, and the most common one is yield monitor system and contact non-contact sensors. So we can collect the data from the field without going there. So, and the second thing, we need to save all this data in the spreadsheet software or SQL software and upload all this data into the cloud system. Then the cloud system digitize, analyze the data, and finally digitize map. So these are the common digitized data. And then I just here's an example. Then I like this very funny thing. The dark age of the farm data collection end here. This is one of the websites about the sensor. This sensor, when you install this sensor in the field, in the soil, the sensor broadcasts all soil nutrient information. So NPK, the macronutrient, micronutrient, the soil temperature, moisture content, everything. About the 15 different informations is broadcast to you in every hour during the growing season. That means you don't need to go to the field to take the soil samples. Another one is sensor is this, real-time plant tissue analysis. So the big sampling is tissue samples. So taking tissue sample takes a long time, and then is pretty much the expensive. But the small sensor, and then get many information from the plant leaf. So that means you don't need to take the tissue samples anymore. So all these digitized data. So when you collect the data, all this data will go up to the cloud, then the cloud analyze the data for your further management decisions. So it's very cool. And the practice for the digital platform, there are two different types of platform. It's a mapping platform and the business platform. So mapping platform is the climate feasibility is most common one. And then business things is a farmers business network. But right now, all these are combined together, so we need only one. And the last one is wireless communication technology. Yeah, that is the process of the traditional farming to fully autonomy. So without wireless communication system, autonomy cannot be completed. So I like just like this, I try to talk about the some basic idea about the variable rate applications and the data, and then the digital agriculture system. So if you have any questions, you can contact me or you can just email me anytime. Thank you very much.
Thank you very much, Dr. Chang. You can please put your questions in Q&A session here, and at the end of the presentation, Dr. Chang will answer them.
Sure.
Thank you very much.
Yep, I'll be here. Yep.
Do you have my screen?
Yes.
Okay. So my talk presentation is improving nitrogen use efficiency using nitrogen-rich spots as biosensor in crop production. So it's all about site-specific management and it's all about management using soil, crop, environmental information, and using the technologies that we can gather this information and process them to have a better management. So nutrient management. When we are talking about the optimizing the input, it doesn't mean to minimizing them. Optimization means we work with a higher capacity and efficiency of a system. Now here is production, crop production system. And these information and new methods will help us to improve this efficiency and improve the environmental quality and sustainability. We always consider higher yields takes more fertilizer. If we are going to produce 300 bushel of corn, we need to provide equivalent of 300 bushels fertilizer. It should be available to the plant. It's not just provided. So if we provide it to different field, it may not be accessible or available to the plant. And next is NPK are not the only elements that limit the production. So we have Liebig law. Most of the time, one limitation limit your production. We have to find out what is that limitation. So why nitrogen management is important? Nitrogen is highly mobile, and if we don't prevent the leaching, even despite we are thinking about the profit and increasing yield, if we don't consider or watch our leaching, the nitrogen will leach to our surface and groundwater, and it would be a threat to sustainable agriculture and our environmental health. On average, growers in the US apply 160 pounds per acre for corn and 92 pounds per acre nitrogen for wheat, about 7.7 million tons of nitrogen for these two crops only. And a 20% reduction plus optimization of nitrogen usage could save us $2.8 billion annually nationwide. So we are talking about a limitation factor. So here, if the limiting factor, nitrogen, by increasing the nitrogen, gradually the yield will increase. But when we increase it and over apply nitrogen, the limiting factor would not be nitrogen anymore. The limiting factor here is phosphate. So when we are thinking about precision agriculture, we want to find out what are the limitations or limiting factors. So variation in a field result tremendous amount of variability in yield. All crop input, fertilizer, irrigation were the same for these two locations of the field. However, the yield was 4 times more in the area with heavier soil texture in left picture. So the primary step for precision agriculture is zone management. And the philosophy of management zone is managing each crop production inputs like fertilizer and all other inputs on a site-specific basis by subdividing a production field into smaller units called zones and managing each zone individually. So the primary steps are to identify the variations, second, to create different zones, and finally, third, to treat each zone individually. Yield, soil data, nutrient, pest infestation, weather forecast, and all other information can help us to perform zone management. So how to identify the soil variations? As Dr. Chang mentioned, aerial imagery, soil electrical conductivity, sampling, soil map, soil survey. These are all the resources we can use. And if we use them correctly, we can see correlation between these information, soil EC, aerial imagery, yield data. But sometimes for yield data, when we are talking about average historical yield data, if you look at this corner of the field, in a wet year, we have the lowest yield here, and same area, the corner, next year means that the dry year, we will have highest yield or higher yield. So it means it's highly related to the weather. And of course, yield here based on the location will change. But the point is, what was the reason? And the reason was the amount of water we had in these 2 years. So now the question is, flat or variable rate nitrogen application? So flat rate is not recommended because not accounting for field variation, leading to wasteful or over or under use, or overestimate or underestimate the nitrogen. So we have other techniques which we've been using. One is ramp application, which we create plots with gradually increasing nitrogen rates across the plots in the field in different zones. To when we walk with an optical sensor or just visually, we can see after how much move means if we have started the zero up rate to 200 pounds of nitrogen, we will see that the color of the plot will change all the way to 100 pounds, means half of that plot. It means after that, we don't have color changes. So we can consider that is the optimum rate. It's not accurate and is time consuming and difficult to do. Enriched strip, again, we have to create plots with a higher or sufficient rate of nitrogen in different zones, and again go and assess them, compare them with the rest of the field. And these are with the nitrogen rich strip, we need lots of calculation and we have to develop algorithm. The algorithm we develop will not be the same for other region or other area. So here, this is ramp application. We apply we increase the rate gradually, and later we will look at the performance and how the crop would react to the nitrogen provided. And the reaction will be calculated by nitrogen response index, which we calculate the NDVI from the nitrogen-rich strips area divided by nitrogen from the rest of field, which we didn't provide the that enrich rate. And when we get this one, we will find out how they are doing. So this is the project for developing algorithm. We had different rate of nitrogen and we developed the nitrogen, but still something is missing. Even though we can do this one real time, we place the nitrogen rich strip, and while we are moving with tractor, our sensor, we can read the rate from the field and from the rich strip and calculate. It was not satisfying method, because all the time these algorithms should be updated and would not consider the weather conditions. So now today we have remote sensing, AI, and biosensor rich spots. I want to explain how these components can help us to improve our nitrogen management. We are talking about remote sensing. Drones offer high resolution and localized insight from field. We fly over. It's just a matter of hours. We collect lots of information from one section, and we can use that information. Satellite imagery would cover very larger areas, enabling broad scale monitoring. And for Sentinel, for example, we have it every 5 days. And we can use it in this method which we designed. So now we are talking about AI, which help and provide us computational power, efficiently calculate and help us analyzing the complex big data, agriculture big data. It will help to predict the nutrient needs and optimize the application. And in the future, we are hoping that we will, based on the AI platform, we will have a smart data-driven decision tools to improve nitrogen use efficiency. So the challenge is unpredictable weather changes, but when we use the nitrogen-rich spots, we could somehow overcome these unpredictable changes. Means no matter what the weather is going to be hot, warm, wet, dry, we will have something there from plants to observe the situation and conditions and send us a signal that I am doing good, or if you provide me this much nitrogen, I can do better. So I mentioned this one, that when we have different algorithms for different region, it may not work for us. So for that reason, we need to develop it. And this is challenge most of the time for other previous methods. We didn't see this problem with the new method we developed. So what's the method? Let's talk about enrich reference or biosensors. We choose some spots, and I will explain how we select these spots. And we apply, just like enrich strip, enough and sufficient nitrogen to those spots that plant cannot take all of that. It means for sure we want to make sure the nitrogen is not the limiting factor for those spots. So when we provide nitrogen for these spots, we will assess the performance of those spots, compare them with each other to see which zone would show better response or reaction. And also we study or assess and compare the middle of the spot with around itself, which we didn't apply nitrogen. So that will give us different level of information that we can use to assess the needs. It means, for example, if you look at my cursor here, this spot showing higher growth rate, it means it becomes darker. It means a better reaction. Compared to this one, not much. So these parts, these plants are screaming, if you provide us this much nitrogen for this zone, we can do better. We can just do like this. So based on that, you can apply more nitrogen here, but not here. Or similarly here, we applied nitrogen, but plant didn't take it. Why? Maybe the limiting factor was something else, or there was enough nitrogen there. So just like what Dr. Chang mentioned, we use NDVI and we introduce another index, that excess green. So we use this one addition to NDVI to see the growth rate, and we introduce this growth rate index based on the nitrogen application we applied for the center, and we compare it with around it. So we started this project on 2022, and for proof of concept, we had one wheat field, and now we tested this project on 4 fields, and for wheat and corn. On both, we had really promising results. Today, I'm going to talk about one wheat field which we had. We created different zones using electrical conductivity, and we tested the soil as well, because we wanted to make sure that when we are using electrical conductivity, those are correct numbers. So we placed our spots. These are our spots, the circle one, and these are our plots, sampling plots. And here was our control area. We compare the inside spots together, and based on the NDVI and green, excess green factors. And because we had differences, these angles here, which we have one from inside, which is different from outside. These are showing the reaction of the spot compared to where they get nitrogen or they didn't get. With just like the outside, they didn't get nitrogen. The inside got the nitrogen. They react better, and they could show the response which we wanted to see when we apply nitrogen. So we compare the spots together and inside outside, and here our recommendation. Based on, if we wanted to go based on historical data, yield data, we should have applied 80 pounds of nitrogen for green, let's say 70, 60, 50, just like recommended based on the yield data, historical yield data. Our drone recommended to put 198.88 pounds of nitrogen in green, compared to 80 is more. And for light green, we had the max we had to apply, and yellow and red was reduced by let's say 30 pounds. So we were thinking, If we do this, even based on the equation we had for nitrogen use efficiency, we will not get anything here. So we integrated the data. We have the weight of the previous historical yield data 20% and 80% from our drone base rate. And we wanted to have the saving also. So we had a upfront 18% of the nitrogen cut, and the final rate was this application. So as you can see here, the drone says 11.1 pounds of nitrogen, but we couldn't apply that much. So we end up applying 25.03. But rest of them, we reduce the rate per acre. When we harvested, the yield, except one zone, which was not significant, all other 4 zones were significantly giving us higher yield. And the protein level was not significantly different, though it was different because we had higher standard deviation. It was not significantly different on protein rate. So nitrogen use efficiency, except one zone, which was light green, we had reduction of nitrogen use efficiency on light green, but overall we increased the nitrogen use efficiency by 16.2%. And here what I want to talk about, when we have the soil data, when we are talking about the soil type or historical yield data, if we have inversion, means some area of the field is giving you less yield one year and next year higher yield, it means you cannot manage it because you cannot predict it. When you cannot predict it, so it's better to have something closer to the time of the application, some other information that are closer to your application, to the side dress application time, the timing. When you want to apply, then you can adjust yourself. Okay, I'm going to adjust my rate now. Why? Because I have some insight, some signals from the plants. Here is the soil data. But here is our aerial imagery. There's no, this area, historical yield data says apply less. But here says, no, if you apply more, I can do better. And so for that reason, our application was changed. This is the prescription map we had for that field. Despite we had the recommendation here to be low. So here, very quick and short outcome and conclusion. So for when we are thinking about environmental outcome and impact, so this method, when we increase the nitrogen use efficiency, for sure, it will have a good improvement on environmental sustainability and quality. And for financial outcomes, by reducing nitrogen usage 16.2% in wheat field, the yield was increased 12.4%, and the potential revenue for that is $65 per acre. And in cornfield, we had a reduction 10% nitrogen use, and the yield increased by 4.77, and the potential additional revenue would be $42.5 per acre. So what we want to see in the future, we want to assess the economic and environmental impact of the method in different locations, more fields. And in larger scales, and we want to study this one to see how this method will work in different locations and different years. And future work, it would be creating a digital tool for the farmers to improve the nitrogen use efficiency, and then we want to make this one accessible to farmers. They can use it. So here is my contact information. We would like to collaborate with you, and if you have any question, please reach out, and I'll take your questions in Q&A session. Thank you very much. And also there is a poll that please consider. It will help us to improve ourselves. And I am going to see if we have any questions here. So if there is no question here, again, I would like to thank you for attending this webinar, and we'll see you tomorrow. We will have a discussion about the precision drainage system and water management. Thank you very much.